Should we start? Okay. Hey everyone, am I audible till the end? Am I audible? Cool. So I'll be talking about retrieval augmented generation. So before we can proceed, I just wanted to have a small activity. So can every one of you stand up for just 1 minute? Just a minute. Okay, I guess it's very tough to stand up because of that seats, but yeah, just a minute. All right. So I'll just ask you questions before I can proceed so that I can understand the level of the audience. So how many of you have built retrieval augmented generation pipeline before? Are you aware of this concept? If yes, you can sit down. If you are aware of retrieval augmented generation, you can sit down. Okay, we'll wait for 1 minute until everyone joins. Okay, so whoever joined us now, can you everyone stand up for a minute? All right. So anyone who has worked with retrieval augmented generation can sit down for a minute. All right. So have you heard of a word called agents? Yeah. If yes, you can sit down. All right. Have you used open source LLMs before? If yes, you can sit down. All right. So majority of you already know what is open source LLMs. Cool. Right. So I'll just start off with my introduction. So my name is Tarun. I'm a data scientist at a startup called AI Planet, and I'm also a Google developer expert in AI/ML. I give few talks regarding TensorFlow, MediaPipe, and nowadays on Gemini and Gemma model, of course. So I also have a YouTube channel. It's named as AI with Tarun. I usually share few stuffs on retrieval augmented generation and also on agents. So apart from this, previously I was also part of Google Summer of Code 2024 at an organization called Redden Labs. I was also part of Google Summer of Code 2023 at an organization called CA Microscope. So yeah, in my free time I watch anime. If in case you hate One Piece, we can have a conversation later. All right. So setting up the agenda for today's call, we'll mainly start off with large language models and its limitations. Once you understand what are the limitations of large language models, we will move on with something called as retrieval augmented generation. So considering most of you are not aware of what retrieval augmented generation is, I'll give you a basic intuition of what it is about and what are the examples. And then we will proceed with what are the challenges that people are facing in order to build this. So let's get started. All right. So I came to Indonesia yesterday and I just wanted to sightsee few locations. So what I did was I directly went to a large language model and I asked about a place called Jomblang Cave, if I pronounced it right. And then I wanted to know what is the entrance time of it and also what is the entry ticket, right? So as a tourist, whenever I ask this query, what should be the response from any application? It should be the time and it should be the actual fees. So if you look at the response that I got, it said, I aim to be direct, but should note that since some specific tourism information can change. Now, if you look at this response, I don't have the time and I also don't have what is the fee of it. So it's not the good way to generate the response, right? Suppose when you're building your own application, you need chatbot to be very intelligent. Hey, whatever question you ask, it should be direct. But in this case, it didn't give me the response, right? So this is where if I prompt it properly. So what do I mean by prompting it properly? I will give the context in beginning and then I'll ask the same question. Now, if you look at the response, it will give you the timing and also it will tell you the fees of it, right? So what is this kind of prompting? This is called few shot prompting. So what happens in few shot prompting is whenever you need better response from a large language model, give certain context. Hey, this is the information about, this is the role that you need to play. Once you define the context, once you define the role, then if you give any query, you'll get a better response, right? So now think for a moment. Is this a good solution? Yes. Why? Because you are giving the context and then you're getting a better result. Now, if you look the other way around, do you think you can give context every single time you give the user query? No, right? This is a very tedious process. You need to give context every single time you write a prompt. So there needs to be a way to automate this process. This is what we will talk in today's session as well. Right. So before we can proceed with retrieval augmented generation, what are the common issues with large language model? We already saw one common issue. It doesn't have the domain specific knowledge and it hallucinated. So hallucination is one common problem of large language model. Then you have out of context, which is your domain specific. And then there is a limit to it. Like if in case I want to know what is happening today, which is real time, GPT or any large language model doesn't have the context to it. Why? Because it is happening real time and the model it's not trained on it, right? So these are the few issues that a large language model always tackle. And then there is one more thing: LLM can't reason and it can't plan itself. There is a lot of debate in it, and tomorrow's topic on agents, I'll be covering more in detail on how LLM can reason and plan. So not completely reasoning and planning, but again structuring it in a better way. Now comes the actual question: how can I connect my data with a large language model? So the problem statement is you have your own data and you need to have a chatbot like Gemini, Claude, ChatGPT, but on your own data so that it can answer better questions. So this is where we have a concept of RAG, which stands for Retrieval Augmented Generation. So let's understand this in a very high level way. So you write a simple question, which we already saw in my previous slides as well. You have a question, and then you have something called as knowledge base. So what knowledge base does is, whatever data you have, you're saving that in a knowledge base. And whenever a user asks a question, you're getting the relevant knowledge out of it. So let's go back and think what we did earlier. So I wanted to know what is the timing of certain place and what is the fee of it. So that's my question. Then when I ask it in a knowledge base where I have the information of all tourist places in Indonesia, now based on whatever information I provided, I'm getting the relevant information out of it. So now you have the question, you have the context, you're giving it to a large language model, and then you're getting a better response. So this is how RAG typically works. But now the question is, how do we get this knowledge base? How do we create this knowledge base? All right, so let's go one step at a time and understand how can you create a knowledge base. When I talk about knowledge base, the first fundamental thing is how do I get my data? And data, it can be in any format, be YouTube video, then it can be a website URL. After my talk, we have a demo. During the demo, we will be chatting with website where our entire data, whatever external data we are taking, it's a website. So let's take an example of video, which is a video for this particular use case. So you have a 2 hours long podcast video and you want to integrate a large language model to this video so that whatever happened during this 2 hours podcast, you need to get the information on it. And this bot, it needs to be intelligent as if like GPT or Claude. So how do you start with it? Once you have the data, you will chunk it. So why is chunking important? If you notice properly the prompt that I wrote, I gave only a small information to it. I didn't give the entire data to it. So you just need to provide the relevant chunk to the large language model so it understands it in a better way. And there are also concerns of context window. Each large language model adds the limit of the context window until which you can add the data. If you are exceeding the context window, then probably it won't give you the answer and it will tell, hey, token limit, I can't give you the response. So this is where you need to chunk your data into a smaller segment. If you have a large data, you segment this into a 25 chunk. So it is based on the token limit. It can be 1000, it can be 512, it can be 2000. And as of now, you're only dealing with text data, whereas large language model or any deep learning models, they don't understand text. Rather, they understand embeddings. So what you need to do is, you need to convert your text into embeddings, and then you need to save that in a vector store. So here we are using QDrun in our demo, which will convert your chunk data into embeddings using fast embed library, and then it will save in a vector database. So why vector database is important? Whenever a user query it is asked, it will return the relevant information. So it will do the search. It can be cosine similarity, it can be anything, right? Cosine similarity is one of the technique. They also use something called as ANN within the library. So now that you understand how you are saving your data in a knowledge base, which is your vector store in Qdren, now let's look into RAG, which is retrieval augmented generation, one step at a time. So first step is retrieval. We start with a user. So user asks a simple query. Let's consider the data that you are feeding it to a large language model. It's related to healthcare. And now you ask a question which is regarding health. The second step is you convert your text into embeddings, and then you will look into vector database and you will perform something called a search. And what search will do is it will return the relevant information in form of context and metadata. So why is metadata important? Imagine you have 20,000 documents and you're adding a large language model to it. Now, when I ask a question, I also want to know from which document it was retrieved. So that information from where the document is retrieved, that information, whatever path you have, it is saved in the metadata. And metadata is very important. It tells you where the data is from. It's not just with the number of documents you have. The second use case is whenever you're building a chatbot for a PDF which has 100 pages, when you ask a question, there might be high chances that a student needs to know from which page number it is, so that it generates the response, and it also tells, hey, whatever question you asked, it is from page number so and so. So this kind of page number data is also saved in metadata. And since you'll be using Llama index, by default, it will add those metadata for you. All right. So this is very important step. As many of you already said that you are aware of what open source large language model, you also need to know that each open source large language model, they have its own prompt template. So you need to define the template so that you don't get any garbage result out of open source LLMs. Few of the example for open source LLM can be Gemma, Mixtral, and the famous Llama models. So now what will happen is whenever you ask a query, you need to have a template. So there are two key elements that you need to define. One is system prompt. So what happens in system prompt is you need to define a role that a large language model needs to perform. For example, you are an expert in writing Python code. So this is a role. And then you need to give certain instructions. So what are these instructions? It can be you only need to generate Python code. If someone asks you C++, you don't need to generate it. So this particular LLM, now it is an expert in Python, and it is given instruction which not needs to be hallucinated. So you define the role, you define the instruction in your system prompt, and then in user prompt, whatever query you are asking, you just need to append it. So these are the two key elements. Once you use the template, now you have the augmented prompt. So there are two things you need to notice now. One, you have the augmented prompt, and one, you have the relevant context. So you have the context and you have the prompt. Now we'll do the same thing. If you looked into my first slide, I passed the context, then I asked the query. Then I'm getting the better response. And my goal was to automate this. And using RAG, I'm able to get the prompt, I'm able to get the context, and then I'll give it to a large language model, which will give me the better response. So this is all you need to know about retrieval augmented generation. Now, how do you use open source LLMs? What are the platforms that you can use so that you can run any open source model? So at first we have Llama CPP. So each large language model, it has the quantized version of it. If you want to run that LLM on mobile or website, you need to use a quantized version of it so that you are not using the more memory and the size of it. So in order to use the quantized version, we use something called as Llama CPP. Then you have VLLM. So what VLLM does is for faster inference, you don't have to wait for a long time to get a response from open source LLM. And you can use VLLM, which has a concept of page retention within itself. And then you have Hugging Face. For the demo, we will be using Hugging Face to load the large language model from the Hugging Face hub. And then you have Ollama. Ollama is very famous and it's most popular as well. If you want to run an open source LLM on your platform, which is on your local system, you can just use Ollama. You need to just write 3 commands and that's it. And even Ollama uses Llama CPP internally, which is the quantized version, so that you can run it in your own local system. And lastly, you have LM Studio. Again, LM Studio, it's pretty similar to Ollama. Rather than using commands, you have a UI version of it where you can load the model and you can use it. So for UI version, you can go for LM Studio. If you want to write application, if you want to write code, you can go with Olama. All right, now that we spoke about RAG, you have the understanding of what retrieval augmented generation is. But if you have already worked on this particular problem statement, you might have come across few common challenges. So there is a nice research paper which talks about what are the 7 failures in retrieval augmented generation, and it can be anything, right? So when I say it can be anything, take this scenario. When I say I want to return the relevant context, what if there is no context itself? When you're using any medical related data, and if you ask a prompt saying what is black hole, so now what is black hole, it has no context with healthcare, so you need not to have any context itself, right? So you might have missing context from your knowledge base. Now let's take another scenario. When you ask a question which is what is black hole, and your data is regarding healthcare, if you have any context and if you are giving it to a large language model, that means you are giving the wrong result to large language model. So this is one more failure point. And third failure point, it can be that when you give proper result to large language model, even though it's not giving you the right result. So these are the few failure methods which we need to address. So we'll look at a few slides on how you can approaches. You need to have a right embedding and right large language model to work on that use case. If you are working on medical related data set, you can use a medical LLM. If you are using anything related to multilingual, like suppose if you have a website which needs to understand Indonesian language, it needs to understand Arabic, you need to have an embedding model which understands those tokens. Now, once you have this embedding model and large language model, we are speaking about open source, which has a very large context, and you need servers and high GPU to host them. This is where, in order to make this entire approach very simple, you will be using quantized version of it. And the last approach is you need the better response. So this is where you need to fine tune. So what happens during fine tuning is, based on your data, you're making that model learn the features of your data. This is where you are using fine tuning. And the best example for fine tuning can be language, which is your multilingual. If I want to build a LLM which understands Indonesian language, I need to get the data of Indonesia, and then I need to train the model so that it understands the keyword. Hey, this is the keyword and this is the meaning of it. So in order to understand these tokens, you need to train your embedding model and the large language model. So this is one way. If in case you're not getting better response, you can fine tune it. And the second challenge is the indexing. So what is indexing? When you have the knowledge base, right, you need to retrieve it. So you need to store the data in your index, which is the knowledge base. So this is where we are using QDrun. And one of the common challenges, when you have 10,000 documents, how do you index it? How can you improve the speed of it? So this is where we have a concept of binary quantization, which will help you 40x memory reduction, which can help with the faster indexing, where you can load thousands of documents in a very less time. And one of the search technique, right? I spoke about search. So what happens is, when you have a vector database, you need to get the relevant information. So you have cosine similarity. One of the additional search method is MMR. MMR stands for maximum marginal relevancy. Get the relevant chunk data. So this is the feature that you can use as well. This is a search type. All right. So the last slide, it will be regarding the retrievers. So when we talk about retrievers, I told a simple retriever. You're just using a knowledge base and you're getting the relevant chunk. And there are different kinds of retriever techniques as well. And one such technique is re-ranking. Now let's suppose when I have the database, right, I want to return how many chunk I need. You have 5 chunk. Out of this 5 chunk, which of them has the more information? You need to re-rank it. So this re-ranking is one such retriever technique. And you also have something called as hybrid search, where you're combining your keyword search with the retriever. Retriever usually has vector search. So when you combine your keyword search with a vector search, this is what you call as hybrid search, when you combine 2 search at the same time. And you have other techniques as well. In our demo, we will be working on hybrid search. All right. So this is the optional side. Suppose if anyone is working on document parsing, that is, you want a proper information, whatever data you have, you need to extract the entire information out of it. Llama Index have something called as Llama Parse, which you can use to extract the information at a very accurate level. So here is one diagram. So probably it might not be visible till the end. you have a bill photo, and when you pass this bill photo to a document parser, there are few information which is getting skipped. It is not able to understand. So using parts, you are able to extract all information in a very precise way. So whenever you have your own data, you need large language model to understand the entire context. In order to understand the context, you need to extract it properly first. This is where llama parse comes in. All right. So we are done with the slides. We'll probably proceed with the demo. And if in case you want to implement whatever advanced techniques you can probably scan this QR code. You have a playlist for it. And this is for the later use. And we are using all open source LLMs. Whatever you're using, it's only Hugging Face. All right. So let's proceed with the demo. And if in case you want to connect, probably I'll show this slide again. All right. So for the demo, we will be using Llama Index, which is the framework which will combine your own data with a large language model, and the knowledge base which I spoke about, and the embedding model. We will be using fast embed from Qdrun and the vector store from Qdrun. All right. So this is the collab node. We will be working on the demo. And if you are unable to open it, you can just search Pycon APAC RAG. Probably you can also scan this and run it in your collab notebook. It can be your laptop. Are you able to open a collab notebook? So I'll wait for 2 minutes so that you can pick it up. How many of you know Hugging Face? Okay. Hugging Face probably is a platform where we're using the open source LLM from. We talked about Llama model, Mixtral, and also Gemma, right? Suppose if you want to use this model, is open face, you can use UF, which is the quantized version. Second way is you can use the Hugging Face. The model loaded on Hugging Face servers, and you can use the model inference. The second way is you can use Hugging Face pipeline, where you are loading the model locally in your system and then use it. So in order to use the third step, you might need GPUs. So that's where we'll be using the second approach, the inference API. I'll talk about this in detail. I'm just giving the clarity on what Hugging Face is about. So all the cool models that you have, right? Like you have any tech, if you want to use the demo of it, they have some. So whenever a new open source, probably you just have to check out Hugging Face. You will have all the model details. It can be model, it can be the space, which is the demo that you can use. And they also have like platform, right? You have open source data set. Even Hugging Face have few data sets that you can use to fine tune a model. So that format, it's available on Hugging Face for a very simple approach, so that you can use it from their libraries like TRL, transformers, and all. Is it done? Is anyone still pending? Okay. So I'll create a new collab notebook. So I'll go step by step. I'll tell you what each line of code is doing and what is So first thing is we need to which is open source, and then you have llama index, vector store, qdrun. This is your knowledge base where you are loading your vector store from qdrun. Then you have again large language model, and then since the data whatever we are using it's related to website, we need to have a frame. This is where we'll be using llama index readers web. So and last you have fast embeddings. So text into embedding. So you can create a collab notebook. In order to create a new collab notebook, you can just go to .research.google.com. Whatever you scanned, right, you can open that in a single tab. You can create a new tab. In that new tab, you can start the code part. If not, you can also run the notebook which I sent. If you want to follow along, you can create a new notebook. So in order to create new notebook, go to lab.research.google.com and then you click on. All right. So once the installation is done, always when you are using Collab, right, it is very best. You need to session. So Collab, it already has few libraries. Whatever framework you're downloading, right, it has dependencies. So in order to avoid this, you need to restart the session. And to do this, you have to click on runtime and you need to click on restart session so that you don't have dependencies works. So first we install and then you click on runtime and click on restart session. All right. So first step, we will understand do we actually use a large language, and we will also get an inference script of it so that you have the understanding of the llama index framework and what are the functions. And second step is when it comes to llama index, right, they have their own default LLM which is OpenAI, and since has the OpenAI credits where you have to pay the credit fee for it, so we'll be using Hugging Face and we need a default LLM and embedding model from OpenAI to Hugging Face and fast embed. So I'll just write embeddings and large language model inference. Okay, so first step is you need to import the statement, and in order to import, we'll be using llama index dot LLMs dot Hugging API. You need to use something called as Hugging Face inference API, and then you have from llama index dot embeddings dot fast embed. You need to import fast embedding model. So why is fast embeddings used in this case? They have something called as Onyx. So whatever in a Onyx format, which is optimized method, and they also have something called as data parallelism, which makes converting your into embedding in a very faster way. And once you import these two things, as I said, by default, OpenAI is default LLM and embedding model. We need to override it. And in order to override, we will be using from llama index dot core import settings. So this is used to override the default LLM and embedding. All right. Here, I everyone are correct, right? Any questions so far? We'll come to the question sessions as well. If in case you have any questions in RAG, we can discuss that. So far, we have only completed the installation step and the import statements. Okay, so now that you have imported, we'll start with where you can ask a simple question and it needs to generate. Open source LLM that we will be using is Mixtral, the instruct model. So I'll import OS and then from getPass, import getPass. So now what I'll do is I'll copy my API key. I'll save that in an environment variable called HF. I'm not saving it in an environment. I'm just using a simple variable, which is HF token. And how do we get this HF token? What you need to do is you need to go to huggingface.co. So the website is huggingface.co. You need to click on your profile icon. So on top right, you have a profile icon once you create your account. If you click here and go to settings, once you come to settings, the next step is you need to click on access tokens. So here is the access token, which is on right hand side. So first thing is go to huggingface.co, click on your profile icon, then go to settings, and once you come to settings, on your left hand side you have access tokens. You just have to click on that. Click on access tokens and create new token. You have to go to write. Once you go to write, you can write any name that you need. I'll just write APAC demo rag. Once I write a token name, I just have to create a token. And now I have the API key. I will copy it and I will paste it here. That's it. So for collab I shared, right? I have written the steps here. So this is the link that I sent to you. You have all the steps of what you need to do to get your access token. Once you get your access token, you need to override in your HF token. In our case, I'm using something called as getPass so that whatever keys I add, it's not visible. In your case, you can directly add in an environment variable or you can save it in a simple variable. Okay. This step is done. We'll wait for 2 minutes so that you can get your keys and you can set up your large language model. So what is happening now is I have a model name, which is Mixtral instruct model, and then we are loading the model. So how are we loading the model? We are using Hugging Face API. You need to model name, Hugging Face token name. Then these parameters are very important. Let's understand what this each parameters does. So whenever large language models you are using, you have a variable called temperature. So if temperature value, if it is close to 0, which is 0.1, 0.2, that means you have to tell the model not to create randomness in generating the response. So when it is close to 0, LLM, it is less creative. If you want LLM to be more creative, give randomness response, you can increase temperature value close to 1. Okay, if you need randomness, have your value close to 1. If you don't need randomness and if you don't need the creativity, have it very close to 0. Since I'm using my own data, I want LLM to stick with the data and it should not give wrong results or hallucinate. So that's where I'll probably keep temperature value very close to 1, close to 0, sorry. So now that you understand what is temperature value, the next thing is you need to use something called as max new tokens. So I've written max tokens. This is max new tokens, and this should be 1024. This is very simple, right? What max does is whatever response you're generating, there is a limit. You can only generate till 1000 tokens. If the response it is exceeding more than 1000 tokens, it will just remove it. It will truncate. So this is the limit that you need to define on how much output tokens you need to generate. This is very important because if you are working with source LLMs, for example, OpenAI, Gemini, or Claude, each token values you are supposed to spend certain dollars. If you extract 2000 tokens, if you extract 4 tokens, there might be high chances that you're generating the tokens, but those are not required, right? So you can save your cost by defining the number of tokens you need to get. If you are just using a chatbot, so how much tokens does a chatbot need? Hardly 256 or 512 tokens, right? So you need to specify proper token based on your use case. So in our use case, I'll just 24, or it can also be 512. Let's keep 512. And then this is important, repetition penalty. I'll give you a scenario why repetition penalty is required. So if I ask a capital of India, and if I get the response, New Delhi is the capital. Now there might be high chances when you're using open source LLM, additional tokens will be generated and it will repeat itself. So you have a response, the same response might repeat times, it might repeat 5 times. So in order to avoid the repetition of the tokens, you need to set a penalty. So this is where you use something called as repetition penalty, and the value it needs to be 1.1 or 1.5 in between that, so that whatever repeated tokens you're getting, you can minimize it. So this is a very common issue in large language models with open source thing. It will generate same tokens multiple times. So you can avoid it using repetition penalty. And the next thing is return full text to be false. So what happens is when you're with retrieval augmented generation, right? Sometimes large language model will give the context itself in the response. That is whatever you're asking, right? With question, you also have the context. So when I'm giving the response to the user, do you think you need to return the context and question to the user? He already knows, right, what the context is and what is the question. He doesn't need to see it. So in order to avoid it, you just have to use iteration penalty, return full text to be false, so that you can only give response to the user and not the context and the question. All right. So I hope you got the Hugging Face token, and I'll wait for 1 minute so that next LLM to ask question. Just a who your Hugging Face tokens. Okay. So what I'll do is post the key so we can save our time. Many of you don't have your Hugging Face account, so I'm key. You can copy this token and you can use it in your application, whatever you're building. Just know whatever I sent to you, right? I'm able to see this. I've just copy pasted in the same collab notebook that I sent. This is the URL. Open this URL and see if you're able to see the token. Are you able to? Yes. Okay. So now that you have assigned a large language model, the next thing is you need to run a simple user query. So what I'll do is I'll ask a simple user query. I'll just ask what is the capital of India. And I'll just print llm.complete.query. One thing, when you run llm.complete and then you give any query, it will generate a object. Out of that object, you just need to extract the text out of it. And that's where after you run this, you just have to write text, txt. Are you able to get the response? You can ask any question that you need. Let's see if large language model is able to understand it. Mixtra is a France-related LLM. It is from the French origin. You can ask any question to generate French response. So you can play around with it. But since many of you are using same API, there might be high chances the number of in per second. So what you can do is batch by batch, you can try any query that you need. If you every one of you, if you run at same time, there might be issue with the same keys at the end of the application that we built. So let's for 1 minute, and then you can try whatever you need. Right. Now, large language model is in place. The next thing is we need to define an embedding model. So now what fast embeddings will do is it will model locally, and two things you need to notice is what is the size of the model. Second thing is what is the model name that you need to use. So model return anything, it's using the default. How do we pick a model name? This is a big question because there are so many model, and how do we recognize what to pick and when to pick? So this is where you have something called as MTEB leaderboard. You can also search for embedding leaderboard. If not, you can search for MTEB, and then you can click on this. You can see whichever model is performing better. If size of embedding is less than 1, or if it is between 1 to 2, use those models. Again, I'll repeat, in order to see which is the better embedding model, you have a leaderboard for it, which is MTEB leaderboard. Taking some time to load. And yeah, you have these embedding models. So what you need to do is you have to click on any embedding model, go to that repository. This thing, whatever you have, right? This thing you need to copy paste in your fast embeddings. So when it comes to fast embed, they have selected models which they can use for fast embedding to convert that into Onyx format. So one model which I usually use is NLP or GTE large. So this is a embedding model that you can use in your fast embeddings as well. And probably at the end of the demo, I'll show you one GitHub repo where you have around 20 notebooks for RAG. You can use that for your reference. And in most of that notebooks, what I've used, this is the embedding model, GTE large. Right, so now let's proceed. So now that the model is loaded locally, you just have to see if you are able to convert your text into embeddings. So I'm just writing an embeddings variable and then embed model. So what is this embed model? Fast embeddings, embed model dot get text embeddings. Previously what we used something called as complete to do the text generation part. And here what we are doing, whatever text you have, see what is the converted version into vector format. So you're converting your text into embeddings. So as you can see, this is in a vector format. And now you pass this vector format into your vector database, and then you perform cosine similarity and search to get the relevant context out of it. So it becomes very easy if it is in a vector representation. All right, so two things is we are able to use a model. The second thing is you are able to use an embedding model. Now the third thing is you need to override it because the default is OpenAI. So in order to override, since we have already imported settings, just copy this settings dot, it is LLM or check. Yeah, it's LLM equals to LLM, which is your Hugging Face. then settings dot embed model equal to embed model. So the large language model and the embedded models are in place, and we are over the default one so that you can use it for the retrieval augmented generation. If you are till here, what you can do is you can open any website that you need, which has text information, copy that URL, and we will build a retrieval augmented generation out of that website. And in our case, I'll be using a Medium article which I wrote, which was regarding Google Summer of Code project. I'll be using that URL. And if you want to use the same URL, you can just copy it here from the collab notebook. This is the GitHub Medium article URL, which I'll be using. So the text is load your own data. And what is the data? It's a website URL. And it can be any website, but just make sure that it has text information and not just images. So this is the Medium article which I'll be using. So it has text information. And I'll just ask few questions which is mentioned in this article just to make sure that large language model is capable to generate the response. If it is not capable, fine tuning is an option. And there are also, as I said, there are also many advanced techniques like retriever, re-ranking, hybrid search, hide. If in case you're not getting better response, right? It's just like machine learning. You don't know what model will give you better response. So you just train a new model, it KNNs, CNNs, what is that, SVM. So there are different machine learning models, right? You don't know which model you need to use for classification. Same thing for retrievers, same old school of machine learning. You just have to play around which retrievers give you better result. You can use those retrievers. So the steps is simple. You can copy any URL you need, and you need to pass inside something called as simple web page reader. And once you close the bracket, you need to use something called as load data. Inside load data, you need to add your information. If you want to talk with multiple websites, since you're using a list, you can add 2 URL inside a single list. I hope everyone knows Python, right? Okay. Is this step done? Are you able to load your document? You can just print and see if you're able to see your context in your documents. You can run print documents. So if you see, I'm able to see the entire context that I have in my website, and I'll also show you the metadata. So if you see here, you have few metadatas. So here it is empty. There are few more metadatas. Probably if you look at below the website, you will find it. And usually what metadata contains, it can be the path of your website. It can be, if it is a PDF, it will be page number and path. For website, it will just be the website URL and the title name. So title name here, Google Summer of Code 2024 Redden Lab by Tarun Jain Medium. And then you have the actual information. So where is the actual information? The actual information is inside content. If you see these content variables. There are two libraries which are commonly used for retrieval augmented generation. One is Llama Index and one more is LangChain. So in LangChain, it is called page content and metadata. For Llama Index, metadata and content. Are you able to see your data within documents? Okay. So the next step is, if we look at the slides, you have your data. The next thing is you're converting data into chunks. So by default, whenever you're creating the index, you are using this chunking within itself. So what you need to do is you just have to skip this step. There are either you can use the splitters. If not, you can use the default one. To save our time, we'll be using the default. And embeddings, it is already done. We have used fast embeddings. So now the next step is you need to set up your vector store. So let's define the vector store. Vector store qdrun. So there are three ways we can do this. There are three ways. So what first way we can do is, in our demo, we will be using location which is in memory. Whatever indexing you're creating, it will happen in your system. Second thing is you can use something called as localhost, where whatever index you're will run on some local server. Third thing is you can use qdrun cloud. So all your data will be saved in the cloud. So since the agenda is to keep everything open source, we will be in memory. So one is localhost, and one more is location in memory, and third thing is you can use cloud by creating the cluster URL and API. Information I have written it here in the Collab notebook that I have shared, so you can check this in the later purpose. Let's go step by step again. What you need to do now is, since we need to create an index of the vector store, you have something called as vector store index in Llama Index. And I told you we don't have to perform the chunking. Why didn't we perform any chunking? Because by default, it is already done in storage context. So we will be using storage context for loading your vector store in the context first, and then using the chunking out of it. So this three process, chunking, embedding, and then saving in a vector database, this will happen inside storage context. Once storage context has the knowledge base, you need to give the actual data. That's where you have the vector store index. So these are the two things. And now where are we getting that vector store from? You need to have certain vector database, right? So we'll be using qdrun vector store from llama index dot vector stores dot qdrun, and then you just have to import qdrun client. So why qdrun client? So here I mentioned about 3 steps, right? Which step are you supposed to use? So out of that, you need to pick one of them. So that step, whatever you're picking, it needs to be within import qdrun client. So I'll just copy it. So we are using location, and then make sure you're giving then memory. So now what will happen is, whatever index you're creating, it will be saved in the Collab notebook itself. Anyone got any error in this? No errors, right? Any errors in this step? So usually at this step, some people get error because sometimes it doesn't connect properly. If you are able to run this cell, then probably we can proceed. And just make sure you give this colon properly. Colon, memory, colon. Okay, so the next step is, there are different retrievers. As I said, you have a normal retriever which will do the search, and simple search is one retriever which you call as vector search retrievers. Now there is one more technique which is hybrid search. So hybrid search will combine your keyword search and vector search and then give the result. So why is this important? Let's take an example. You have a medical related database. And now if I come and ask what is black hole, what vector search will do is it will just look into the embeddings and give you the context. But what keyword search will do is it will look at the keywords such as black hole. There is definitely in your data set you might not have a word called black hole. So your keyword search will in not giving the context. So keyword search will look at the keywords and then retrieve. If black hole, it is not there in the data, it won't give you the information. So this is where having the combination of two vector search is very important. So we are using keyword search and search, and this is what you call as hybrid search. In some cases, it is also called ensemble retrievers if you are using LangChain. So what is the collection name? Collection name can be unique for each data set that you give. And in my case, I'm giving GSOP, which is Google Summer of Code. Why? Because my data, it is related to GSOP. If whatever data you have passed, right, the URL, if it is unique to some field, you have to give any name. Whenever your data changes, make sure the collection name is also changed. Don't use same collection name to same data, two different data. And then you have client. What is client? Client will define where QDrunt is currently hosted, which is in memory. And then you need to enable hybrid to be true so that you can use hybrid search. Batch size. Batch size is very important because if you are using any keyword indexing, right? How much batch of your data, which is your document, you need to pass inside your vector database. So this batch size of the document to vector database is defined by batch size. And once you run the cell, it will run a few files which is using file. And why is this? Because you have defined this too. Again, if you notice it format, that means internally QDrunt is also using fast embeddings. So we are done with the third step as well. So the first step was getting your embedding an LLM model. The second step was loading your data. This third step was to defining your vector restore, which is QDrunt. The fourth step is we will create the index. Any errors till now? Okay, we'll wait for a few seconds. So you can just add a title again, and I'll add define index. Okay, so let's proceed. Now, in order to define the index, have your vector store in place, and you have to use storage context. Why? Because we didn't perform any chunking, and in order to override the chunking, right? Again, you can use the same approach. You can go to settings, then you can use something called as chunk size to define your chunk, and then you can use chunk overlap. I'll give you an intuition what chunk overlap is. Suppose you have 2 hours long podcast video, you're using chunking, which is of 512 tokens. So the entire video will be converted into 512 tokens. Now, if you need any information from chunk 1 to chunk 2, you need to give a overlap value. So this chunk overlap, what it will do is, if you are giving 50, chunk overlap to be 50, that means from my previous chunk, take 50 last tokens, and it will be the first few tokens of the second chunk. So it's like, I'll show you an intuition. Suppose you have this chunk 1. So the last 50 tokens of the chunk 1 will be the starting of the chunk 2. Plus those 50 tokens. And this will repeat. For chunk 3, you will have 50 plus chunk 3. So this is what you call as chunk overlap. And this phi 12, it's nothing but the chunk size. There are two parameters. One is chunk size and one more is chunk overlap. And I'm using the default one itself, so I'm not hiding it. And what is the syntax? If you look at the notebook that I shared you, this is the syntax. Settings dot chunk size, which is phi 12, then settings dot chunk overlap, it is 50. So this is by default and I don't want to change it. That's why it is in the comment. All right, so now that we know storage context, the first step is done, chunking. And then since you're using the defaults, you need to override vector store to vector store. So what is this vector store? It's the qdrunt vector store. And default, it runs in memory. And I don't want to store my data. That's where I'll be using vector store from the qdrunt so that I can use hybrid search. And once this storage context is, you need to run your indexing. In indexing, you just have to combine your document with a vector store. So you're passing the document and then you're passing the storage context. So this step will take around 1 minute, 2 minutes, depending on your data. If the text data it is very long, then probably this might take 1 to 2 minutes. And if you have 20,000 documents, 10,000 documents, this might also take an hour or 2 hours based on your data limit. So let's see how much time it takes. In my case, it should be 1 to 2 minutes, not more than that. So this is one of the challenges that usually people face when you are working with retrieval augmented generation. And this happens only once. Once you create an index, you can use as many times that you need. And every time the data changes, your index changes as well. So for one single data, so only I said, keep a unique collection name so that whenever you want to use it, you can reuse the index. Because indexing takes time. You can ignore the warnings. So it took around 57 seconds. Since there might be few people who are using their own URL, just let me know how much time it taken. I'll wait for 1 more minute. Has anyone used different URL for RAG, or are you using the same URL that I'm using? Different one. Is it done? Okay. Is it done or is it still running? Okay. Now I'll explain what to do after indexing. So if you are using memory, suppose if you want to include memory in your retrieval augmented generation, so that whatever conversation is happening, you're saving that. So if that is your end goal, you have to use something called as chat engine, which we will look in the second half. And second thing is, if you want to just use a query, like whatever information I have in context, I need to just query it. That's where you can use something called as query engine, which will get the automated context. And then you will ask a question, which is a simple RAG. Then you can use query engine without memory. It will not save your previous conversation. Chat engine will save your previous conversation. And third thing is, you can use something called as retriever. So index retriever, it's important. Sometimes you need to evaluate it, whether this approach is right or wrong, which is the optional part. I won't write the code, I'll just tell you. Three commands you can run: chat engine, query engine, and is for retrieving. So how do we get that? You can just run index dot. So you have as chat engine, then you have as query engine, then you have as retriever. So this is the three things that I spoke about. So we will be using query engine. I'll just write query engine equals to index dot as query engine. And since we are using hybrid search, you need to use enable hybrid to be true. I'll just check the syntax of it. So there are two steps which we have completed. Out of retrieval augmented generation, we completed generator part. So retrieval part, it's nothing but your index. Generator part, it's nothing but your query engine. Now what is the leftover part? It is A, augmenting your prompt, which is left out. So before I proceed with augmenting prompt, you can print the query engine and you can check the prompt that is being used within the Llama index library. So the command for that is query engine dot, probably it is get prompt, get prompts, and I will print it. So this is the prompt that this here. You have something called as template. Sometimes write their but LLM doesn't hallucinate. Since it's a framework, they have its own prompt as well. So now if you look at the default prompt, it's saying context information is below. Given the context information and not prior knowledge, answer the query. Simple. So that large language model, it is given an instruction that, hey, just use the context which is provided and not the knowledge it is trained on. So that model will not hallucinate. So this is one technique to reduce, but not completely remove hallucination. Hallucination will happen, but the reduction it's less. So now what we will do is we will override the prompt. So let me copy the prompt. Reason why I'm creating a own template rather than using a default template, it's because I need to use these tokens. If you notice in my slide, I use few tokens as start. S it's nothing but you need to start from here and end it. So these are the few tokens that this is the format of that particular large language model, and this will change for other large language model. For example, Gemma might have start of turn, then end of turn. Llama has a different syntax, different syntax. So you need to define that prompt template so that you don't get the garbage result out of it. And the prompt is again same. As I told, I usually start the prompt by defining a role play. So the role play here is, you are an helpful AI assistant. Use the following piece of context to answer the question at the end. So what I need to do, I need to pass the context and I need to get the query. I'll just run this template. And you can define your own prompt. But the only thing that you need to keep in mind is change this input variables. So whatever you have inside curly brackets, these are called input variables. I'll just write a command. The variables inside curly brackets are defined as input variables. And why? How did I get to know what is this context XTR and query STR? When I print this, right, you can notice here you have query STR and then you have context XTR. I need to use the same variable when I override. If you just give context and query, it will hallucinate and it will throw an error. So make sure you use the same input variable and nothing else. So one is context str, which is string, and then query str. And once this is done, you need to define a prompt template. So from Llama index core prompts import prompt template. Okay. So I forgot the underscore. It's from llama index.core import prompt template. And I will just do something called as prompt. And you can define your prompt template inside that. So once you define your prompt template, you just have to override the existing prompt by running update, and you have to give the key. So what is this key? when you run get prompts, right, it is a dictionary format. So since it's a dictionary, you can override it since it's mutual. So I'll use the dictionary and I will override existing prompt in new prompt. That's it. So now you're able to complete your retrieval, you're able to complete the augmented and the generation. The only thing that you need to do now is bring a user query and then generate the response. So we'll be using two user query. One query, it is out of context, which is not one context, it is the data that you have. So that we want to see whether it is able to give the result, and if it is not able to generate the results which is not in the context. For example, when I have a website, I don't have any information on lifestyle or any other thing. So my first prompt will be, what is meaning of life? So what is meaning of life? This question is out of context. And second context, whatever I ask, it will be from my website. So I just wanted to compare the result. So let's run two user query and see what is the response. So I'll run query one. Query one is, what is meaning of life? And query 2, I'll just write, what is the goal 1 of the project. So these are the two queries that I'll be running. Now since you have query engine in place, copy this and I will write response 1 equals to query engine dot query 1, and I will print response 1. It's telling empty response. That means it has not hallucinated. Now I'll run response 2, same syntax, query engine dot query. I'll give query 2, print response 2. Okay, let me rerun this again. I'm running the index again, and I'm just rerunning the cell, but the syntax is same. Once you have query engine in place, you just have to run query engine dot query whatever user prompt that you need. So this is what I got when I run in the morning. So when I asked what is the meaning of life, I am an AI and I don't have personal belief or ability to determine the meaning of life. So it didn't give me a response. And when I asked about what is the goal 1 of the project, it gave me the response of goal 1 of the project is preparation of the data set to fine tune on LLMs. So this is from the data which I have. So this is how retrieval augmented generation is built, and we looked into the query engine. The second part is the chat engine. But now let's take few questions, and then I'll start with the memory integration, which is optional part. I'll just show you how this is built. That's it. Any questions? Okay, documents, there is no limit. You can, as I said, you can bring 10,000 documents, 20,000 documents. The limit will come in how do you index it if you have that much of load in your vector database. Because database, if you are using open source, for example, Fias or Chroma, they have 4 GB of RAM or capacity. So only up till then you can save your index. So this is where you can upgrade to their cloud services, or there are few services that you can use. Cloud, you have sorry, not Cloud. You have Qdrun, you have VB8, you have Milvus. So these are the three common vector database which people use for large documents. So the limit is based on the vector database. There is no limit.
shows the response correctly. But when I change it like what is the goal of the project, it gives me empty response. But it only works on Go in my case. I don't know why.
So sometimes at query engine we just have to rerun. There might be some issues with the query engine. That yeah, index.
Why is it happening?
This issue even I was facing yesterday. Like usually what happens in Collab notebook, right? Sometimes the sessions are not updated, and the location of your it is in Collab. So that sessions need to be updated when you run that cell. Yeah, it happened to me just now. As you can see, it's empty response. So that's why I showed you.
But if it is running on a single VM, we won't expect that.
I didn't get
Because
it.
it is your shared resources.
One common issue it can be because of the location is in memory and sessions they are not running a sync. The second issue it can also be that I don't know how many of you are using same API key at the same time. There might be high chances that the model which I'm using, since it is on Hugging Face and I'm using the free API token, there might be chances of if I'm doing multiple API calls at same time, the LLM is not generating the response. So your LLM is getting none. So that might be the second issue. So let me try with Gemini, and probably if I use Gemini and run the same thing, if I get the result, then probably the issue might be because of multiple LLM calls at same time. If anyone is using their own API key for Hugging Face, are you able to get the response?
I use my own one, still have the same one.
Okay, but you got the first response, right? Okay. It might be because of the session as well. Which one? Here. Here it will override. So now what will happen here is this response it will take from here and it will generate. Then I'm overriding it. So now what this response will have is it will have the information of the second query. Okay, you mean response dot response, right? Okay. So when you print this, right? This is an object actually. So this is an object. So what I need is from the response one, I only need this response. I don't need this extra information. So when you run just print, now what I'll do is same response one, if I write inside print, I'm not getting that result. So that was just to show you the difference. If you directly run print, you won't get that. If you just run response, you will get the object. From that object, you need to get the response. Any other questions before we proceed with memory integration? It can be from the slides as well, if you have any questions from slides. Okay, I guess we have 15 more. Okay, there are two pending things now. One is the memory integration, and second thing is the optional evaluate. Evaluate, it's a thing that you need to use for every RAG app you use, because if you're working on this on a production grade level, you need to have that thought clarity whether this approach what I'm taking it is right or wrong. So if you have a benchmarking score, then you will understand, hey, this is the evaluation metric, and this approach what I'm taking is better for this use case. So I'll also show you how do you actually evaluate it. And you have all the source code available. I'll share you the links for that. Okay, now I won't write the code. Rather, I'll directly give you a brief of memory integration and the evaluation part. The approach is same. You have the indexing, which has vector store index, and then you are running query engine. So instead of running query engine, we will use something called as chat engine. Okay, so now you see index dot as chat engine, and inside that you need to give memory. So in order to use memory, we have something called as chat memory buffer. So now what chat memory buffer will do is, suppose you have done 10 conversation. All 10 conversation will be saved in a buffer of the token limit. If the token limit is 3000, all the 10 conversation that you have will be in that memory. If those 10 conversation, if it is exceeding than 3000, then only the last 3000 tokens will be there. For example, let's suppose you have 10 conversation. From second conversation to 10th conversation, you have 3000 tokens. And the first token that you have, or first conversation, you have 100 tokens. So those 100 tokens will be truncated. So only the previous 3000 tokens will be considered for your chat memory buffer. So token limit, you are defining your memory. And second thing is, you need to define a chat mode. So there are 5 different chat modes in Llama Index. The only 2 chat mode that you need for retrieval augmented generation is context, and one more is condensed plus context. So what condensed context will do is, it will give you more flexibility to define the context prompt. And you can use anyone. Either you can use context, so either you can use direct context, or you can use condense plus context. And how do you get to know the information of it? Just over here and wait for a few seconds. So index dot chat. So if you see here, you have all the chat mode. So the first chat mode is best. The second chat mode is what I spoke about, context. Chat engine that uses a retriever to get the context. This is what we need. And then you have condense plus context, chat engine that condenses the question and uses a retriever to get the context. So you can pick any one of this, either context or condense plus context. And once you have defined the chat memory, define the memory as well, and then the LLM and the context prompt. So if you look at prompt, it is same prompt that we have used in the template. So you are an helpful AI assistant, use the following piece of context to answer the question. So this is the same prompt. And then verbose is false. So what verbose is, like whenever you are running anything, right, what is happening in the backend? If you want to see the information, you can keep verbose to be true. If you can keep verbose to be false. And once you define your chat engine, you need to use something called as chat. Previously, what we did, we defined a query engine and we ran query. Here, what we need to do is, you just have to define a chat engine and run .chat. So now if you see here, what is the data about? It will give you the information. And next time when I ask, based on the previous question, what is goal 3? So it has the understanding of what happened in the previous question. So the two things are, only you have to use a different engine, and then instead of query, you just need to run chat. Just make sure that mode, either it is context or it is condense plus context. That is by default best, and you need to change that. The only part that you need to keep in mind, this one. Even if you don't define a context prompt, you can use a default one, but I don't usually use default one because this is a very important, the role play thing. And once that is done, you are able to run the particular chat engine and get the information. Now the final part, which is the optional, how do you actually evaluate your retrievers? Here, what I'll do is, I will run a splitter. So previously what we did was, chunk size and chunk overlap, you use the default by storage context. Here, we are defining it explicitly in the sentence splitter. Now in sentence splitter, you are defining the chunk size and you are creating the node. Node, it's pretty similar to chunk that you have. And once you have this node, what we are trying to achieve, I want to know how well my retriever is, right? What is the role of the retriever? Based on the user query, I want to return 2 similar contexts, 10 similar contexts. So this similar context, whatever I'm extracting, are those valid enough? What is the metric behind it? So there are 2 metrics. One is hit rate and one more is MRR, which stands for, I forgot the full form. It should be reciprocal rank. Yeah, mean reciprocal rank, MRR. So these are the 2 metrics that we to define how well your retrievers is. And in order to again, you have to use vector store index. Indexing is very important because there are three things: query engine, chat engine, and as retriever. So we need as retriever. In order to get that as retriever, you need to index. So once the index is defined, you are using as retriever, and then you need to return top k, which is your two similar context. You can change this value. In my case, I'm just retrieving the two relevant. And once this is done, you have to use llama index dot core evaluation retriever evaluator. Inside that, you have to pass the metrics that you need and the retriever. So this is the only piece of code that you need. First, we split the data into chunks, and then you have to use the separate evaluator, which is your retriever evaluator, and you need to define your metrics, iterate and MRR, and then just pass your metrics and the retriever. How do you get the retriever? By index. So there are three functions in index that everyone needs to keep in mind: query engine, chat engine, and retriever. That's it. So this is a once you have your retriever evaluator in place, you need to generate few questions. What question? When it comes to user query, right? User query, it can be anything. So you are using an LLM to generate the user query and see what is retrieving user query. Where we are generating a fake data set or generic data set for evaluating from the database itself. And this concept is what you called as LLM as a judge, which is judging based on itself and generating few set of questions. Based on two set of questions, asking, okay, what is the relevant context? Get those context and then run the evaluator. So it's a very simple logic. You just have to define this line of code. Generate questions context pair. You have to pass your data. So what is the data? It's in nodes. If you notice here, your documents, whatever you had, it is splitted into nodes. This nodes, you're passing inside your QA dataset. And once you have the QA dataset, you have a question, which you need to ask for the evaluator. So this is only for the advanced user. That's why I've added in the optional. If anyone is already aware of RAG, this is one approach that usually people use for evaluating your retriever. Yeah, that's it. And if you have any questions, probably you can reach out to me here. Happy for taking any questions. If not, we can also discuss after this talk. Okay, so usually the best practice use 756 as a chunk size and 200 as a overlap size. And there are few libraries which you can use hyperparameter tuning. Llama index also has hyperparameter tuning. So what happens in this step is, based on your data, you're running that hyperparameter tuning to get the chunk size and chunk overlap. So since it is an hyperparameter, you don't have the exact value for it. But most of us, we use 756 and 200 is the chunk overlap. Yeah.
Normal machine learning, we have something like Pycon, right? Like we compare multiple model SPM.
Correct.
Yeah. So for this, we have many models also recognition. You need to
Yeah. So
like automatic the model picking.
automatic is not there. So what you need to do is you have to change the models, and then you have observability tool. So in this observability tool, it will track the latency of whatever models you're using. Suppose if you have 5 models, right? Each model, it will track the latency. It will track how many tokens it utilized, and it will also track the metrics. So the metrics usually used are context relevant, answer relevant, and groundedness. So these are the few metrics that they usually use to evaluate, and you can keep track using observability tool. So Phoenix is one of the example, Phoenix AI, and then you also have TrueLens. So this is the one. Yeah, this is the one. Yeah, it's open source. So you have the repo here itself, and they have the integration with Llama Index. So it's just 2 or 3 lines of code. So if you look at their examples, probably need to find Llama Index. See, it's Llama Index. They have the code for it. Yeah, we have one last minute. Anyone has any questions? Uh, Sorry, I was not audible. Can you repeat again? LangChain. Yeah, so I use LangChain as well. The only issue is the orchestration, right? So there are different techniques that you need to use. Usually, orchestration is very important. How well you are able to generate your code, how well you are able to manipulate or monitor it. So when it comes to this monitoring, observability, and tracking your system, probably Llama Index has better support compared to LangChain. But recently, LangSmith and LangGraph also adds that support. And but still, when it comes to production, I've seen people using Llama Index over LangChain. It's main on the tracking and the monitoring part. But if you're LangSmith with LangChain, then probably it's very similar to what Llama Index is doing. Yeah, thank you, everyone. Thank you. Yeah, it's
I'm also
Oh, nice.
in there.
Oh,
The next one.
yeah.
Yeah.
LangGraph or agents?
It's just reasoning.
Yeah.
Yeah, I know. Launch anything.
Actually, you have React.
But it's wrapped by the launch, by the
Open